welcome to the Daily Space. My name is Annie Wilson, and most weekdays the CosmoQuest team is here putting science into your brain. Today, however, is for Rocket Roundup. Let's get to it, shall we? So, first up, on June 25th at 1332 UTC, a two-stage Terrier-improved Orion suborbital sounding rocket launched 100 student payloads from the Wallops Flight in Virginia. Sponsored by the Colorado and Virginia Space Grant Consortiums, the launch was part of an annual ROCSAT-C program, which is currently in its 13th year. According to NASA press release on the program, participants in Rock On receive instruction on the basics required to develop a scientific payload for flight on a suborbital rocket. After learning the basics in Rock On, students may then participate in ROCSAT-C, where during the school year they design and build more complicated experiments for rocket flight. Let's watch the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Radars 3 and 5 are tracking.
Because of the impacts of COVID-19, the usual in-person learning workshop at Wallops had to be done virtually after the 2020 edition had been postponed. Chris Kohler, director of the Colorado Space Grant Consortium, stated that one big advantage of the virtual process is that participants worked in small teams or individually at their own pace. This led to an increase of payloads from previous years, from 28 payloads in 2018 and 2019 to 66 payloads just for this year. The students built so many payloads covering everything from acceleration, humidity, pressure, temperature, radiation counts that they could only fit 32 of them in the space available. The remaining 34 payloads will be launched into the stratosphere this fall on a large balloon. When that happens, we'll tell you about it here on Daily Space. Just a few hours later, on June 25th at 1950 UTC, the Russian Space Forces launched a Soyuz 2.1 Bravo from the Plesetsk Cosmodrome in northern Russia. On board was the Pion NKS satellite. Because of its military nature, nothing was officially said about the payload by Russian sources except that it was a new generation spacecraft in the interests of the Ministry of Defense of the Russian Federation. Once on orbit, it was given the designation Cosmos 2550. Cosmos is the standard designation given to all Russian and previously Soviet military satellites to conceal their true purpose. In total, 80 soldiers and 50 vehicles were involved in the launch campaign. Pion NKS is the first in a next generation of naval reconnaissance satellites for Russia, combining the mission of two previous series of satellites into one spacecraft. The two missions are signals intelligence and radar. As such, Pion NKS has the capability to identify where ships are in the ocean with the radar, and with the transmissions, signals intelligence equipment, they can see what transmissions are being sent or received. Let's watch the launch. After this break, we'll be right back with more rocket goodness. Stay tuned. Our last launch of the week took place on June 29th at 23:27 UTC, when a Russian Soyuz 2.1 Alpha launched the Progress MS-17 cargo resupply mission from Baikonur. It will dock with the International Space Station on July 2nd at 1:02 UTC. Progress MS-17 will deliver 3 tons of food, repair tools, scientific experiments, and propellant. One of the more notable payloads is the food, some of which is fresh made by the ISS Crew Nutrition Department of the Institute of Medical and Biological Problems of the Russian Academy of Sciences. Each of the crew members gets to choose what foods they would like during their time on the station. These options included things like goulash, borscht, mixed nuts, and jelly meat. What's jelly meat? I'm so glad you asked. Jelly meat is better described in English as aspic. That's literally meat covered in gelatin. It sounds gross, but it is a regional specialty in Russia. And to be fair, we made our own astronauts eat gelatin-covered foods early on in our space program. The gelatin-coated foods was to reduce crumbs floating around, which can cause problems with like getting caught in equipment and air filters and things like that. Anyways, if you'd like to know about the rest of the food that was delivered, you can check that out on our website, dailyspace.org. Progress MS-17 also carries many scientific experiments. One experiment will investigate countermeasures for bone fractures in zero gravity. This experiment is important because bones lose density in microgravity because they are no longer subject to the mechanical stresses of gravity. When astronauts return to Earth, they are at increased risk of breaking bones because of the lower density. An effective way to prevent bone loss in zero-G is to induce mechanical stress on the body through exercise, such as by running on a treadmill. The BioRisk experiment will investigate the impact of spaceflight on blood plasma compounds. One final experiment will investigate the production of medication in zero gravity that can modify the immune system. Progress will also deliver 470 kilograms of propellant for the station's orbit-raising engines, 420 liters of drinking water, 40 kilograms of bottled air, and 1,509 kilograms of other equipment. Let's watch the launch. Today is Asteroid Day, and it seemed fitting to feature current and future asteroid missions. Launched in 2014, Hayabusa 2 arrived at the asteroid Ryugu in 2018. Once there, the spacecraft effectively shot a bullet, called an impactor for science, to expose undisturbed material just below the surface. Hayabusa 2 collected a sample of this unweathered material to bring back to Earth. Because the subject was not subject to weathering from radiation and impacts with other rocks in space, it will give scientists a better idea of the asteroid's properties. It successfully returned those samples back to Earth in December 2020. That doesn't mean the mission is over. The spacecraft will continue on and visit other asteroids, like 2001 AV45 in 2029 and asteroid 1998 KY26 in 2031. These two asteroids are what is known as fast rotators because the time they take to spin on their axis is only 10 minutes. Humanity has not visited an object like this before, so it will provide useful contrast to the rubble pile asteroids Ryugu and Bennu. Speaking of Bennu, after arriving at the asteroid Bennu in December 2018, OSIRIS-REx spent several months imaging the surface in detail to find a suitable collection site. That turned out to be a challenge. The science team was expecting to find a smooth surface clear of major hazards. What they got instead was huge boulders jutting out from an extremely rocky surface with very few smooth areas. With the help of over 3,500 volunteer citizen scientists in CosmoQuest's Bennu Mapper project, who painstakingly marked over 14 million rocks, boulders, and craters on thousands of images from OSIRIS-REx, spending about 45 minutes per image, mind you, 4 sites were identified. Using this information to identify possible sample sites, OSIRIS-REx collected a sample in October 2020 from the sample site called Nightingale, located inside a crater near the asteroid's north pole. The spacecraft began its return to Earth in May 2021, and it will arrive in September 2023. After it delivers its sample back to Earth, it too will continue on to an extended mission. Launching later this year is humanity's revenge for an asteroid taking out the dinosaurs at the end of the Cretaceous period. The Double Asteroid Redirection Test, or DART, is pretty much what it sounds like, a test to see if humanity can redirect not 1, but 2 asteroids. The double asteroid target for this NASA mission is the binary asteroid system Didymos. A binary system is one where 2 objects orbit each other while orbiting the sun. In this case, that system is Didymos and its smaller companion Dimorphos. Before I continue, I want to point out that their orbit doesn't cross Earth's orbit, and there is absolutely no threat of either Didymos or Dimorphos hitting us. I repeat, they will not impact Earth. With that said, the fact that they will never collide with our planet makes it pretty much the perfect test subject for this mission. DART will impact Didymos, and because of that not crossing paths with Earth a bit, scientists and engineers will be able to safely see if humanity can change the orbit of a potentially hazardous asteroid. And its companion Dimorphos, it'll be fine. The kinetic energy resulting from the test isn't high enough to disturb its orbit in a way that would result in a future collision. After the break, we'll be back with rocket history and the stats. Stay tuned. This week in rocket history, we're going to cover the launch of STS-71, the first spacecraft to dock to another nation's space station. When Atlantis launched on June 27, 1995, STS-71 became the 100th crewed launch from Kennedy Space Center. On board were 5 American astronauts and 2 Russian cosmonauts. This was the first time Russians went to space on an American spacecraft. Prior to that, the last time Russians and Americans had worked together directly was on the Apollo-Soyuz test program 20 years earlier at the height of the Cold War. Together, they would continue to achieve several more space firsts for both nations. After 2 days of catching up to the Mir, STS-71 became the first American spacecraft to dock to another country's space station. Shuttle Atlantis came up directly below Mir to dock on the Crystal module. This was the only module the shuttle could dock to, as all the others had the standard Soyuz port, which was not compatible with the shuttle. To make room for the shuttle, the Crystal module was temporarily moved to the forward port of the Mir core. 800 meters away from the docking port, Commander Robert Gibson took over manual controls and brought the shuttle in for a soft docking. His docking was nearly perfect. He was only off by 2.5 centimeters, which is equivalent to an inch. Once docked, Atlantis and Mir formed the largest spacecraft ever at that time, over 225 metric tons. For comparison, the International Space Station is now over 400 metric tons. After docking and opening the airlocks, the commanders of the two spacecraft, Gibson and Vladimir Dezhurov, did a ceremonial handshake, just like their counterparts Thomas Stafford and Alexei Leonov did 20 years earlier. Atlantis spent 5 days conducting human biomedical experiments with the combined American and Russian crews. These experiments covered 7 different disciplines: cardiovascular and pulmonary functions, human metabolism, neuroscience, hygiene, sanitation, and radiation, behavioral performance and biology, fundamental biology, and, of course, microgravity research. Most of these experiments were conducted from the Space Hab module in the payload bay of the Atlantis. Atlantis brought back biological samples, including blood, urine, and feces from these different experiments, as well as a broken computer from Mir so it could be repaired on the ground. The crew transferred 450 kilograms of water, as well as spacewalking tools needed for repairs to the station. Before undocking, the shuttle exchanged crews, leaving behind Nikolai Budarin and Anatoly Solyovev, so Mir Expedition 18 crew could go back to Earth. This resulted in 7 crew members going up and 8 coming back down, which is the largest crew on any spacecraft for launch or landing. Budarin and Solyovev became Mir Expedition 19 and remained on board until September 1995, when they would depart in the Soyuz that had launched Expedition 18. Both craft undocked from Mir, temporarily leaving the station empty. This was so that the remaining crew could take photos of the shuttle undocking. After the photo shoot, the spacecraft went their separate ways. Soyuz redocking with Mir while Atlantis headed back to Earth. 10 days after launch, the 8-person crew landed safely back at the Kennedy Space Center on July 7, 1995. The Shuttle Mir program gave NASA a lot of experience in long-duration missions, space station operations, and working with the Russians. Hardware from the program, specifically the APAS-95 docking port on the shuttle, would later be used on the International Space Station. After the break, I'll be back with your stats and space fact. And we're back. To wrap things up, here's a running tally of a few spaceflight statistics for the current year. There are currently 7 toilets in space, 3 installed on the International Space Station, 1 on the Crew Dragon, 1 on the Soyuz, 1 on the Shenzhou, and 1 on the Chinese Space Station. There have been 60 total orbital launch attempts so far this year, including 3 failures. From those launches, humanity has put a whopping 1,158 satellites into orbit. I keep track of orbital launches by where they launched from, also known as spaceport. Here's that breakdown. USA, 25, China, 19, Kazakhstan, 5, Russia, 5, New Zealand, 3, French Guiana, 1, India, 1, Iran, 1. And your random space fact for the week is that all 4 of the SpaceX barges take their names from the culture novels by Ian M. Banks. Marmac 303 and Marmac 304, better known as Of Course I Still Love You and Just Read the Instructions, take their names from the book The Player of Games. The 3rd drone ship in the fleet, Marmac 302, which is really the fourth, as both Marmac 300 and Marmac 303 were both named Just Read the Instructions. Anyways, that third drone ship will be called a shortfall of gravitas, a reference to experiencing a significant gravitas shortfall from the book To Look Windward. This has been the Daily Space.